Here's the setup that I want to show you. I've got this motor. The motor is from a car seat. It's an Audi electric car seat motor. Cost £9 on eBay. Really loads of oomph. Not fast, but perfect for this. And I've turned it into a servo using a pot. So I've just got this linkage here, so that whenever the motor moves, it moves the pot. The pot feeds back into the Raspberry Pi. I've got the Raspberry Pi Pico over here, and I've got a full bridge driver, which has an eBay special, like 40 amp full bridge driver. Brilliant little board. Actually, it works really well, really cheap. And then the pot here, which is the input to the Raspberry Pi to set the angle of the servo. Over to the software. What I'm doing software wise now. When you first look into Raspberry Pi Picos, it says, oh, you've got to use Thonny, or there's all sorts of other mechanisms. But I found that by far the best approach is to use Visual Studio Code. Visual Studio Code is my preferred editor. It's what I use at work. It's excellent. Now there is an extension. If you go into the extension sections, which is over here, you'll see that there's one called Pico Go. If you just search for it in the top here, just search for Pico Go. This is all of the. This is an extension which adds Raspberry Pi Pico functionality straight into Visual Studio Code, and it's absolutely excellent. So what you get is, let me just go back to my code. What you get is this in the terminal. You've got access. It connects. You can see along the bottom here, Pico connected. You can upload and download files. It has a load of other commands that you can use, including FTP. On and off the device as well, and you can see that what I've got here is the REPL running on the actual Raspberry Pi, so I can actually type Python commands directly in here. So let me see, we'll just do the usual hello world. This is actually running directly on the Pico, which is dead handy. Like when I first set this up, this motor driver board, it allowed me to issue just dead simple commands, PWM commands, to see the outputs changing and just make sure that I've got all the connections correct and everything. So it's really quick and to develop. When you've got your code ready to run, you can you literally, well, the code that I've written for this servo is very simple. It's got a couple of pins for pulse width modulation up here at the top. It has a couple of lines here for the AD converters, for the one for the steering pot, one for the servo pot. There's some constants there to stop it crashing. This is my PD routine, which is very simple. It's not PID. It's very simple. It's PD, which is absolutely fine for slow moving devices like this, and there's no problems with it works very well, and it's dead simple. The maths is really quite simple. Even I can understand the maths, which is saying something. And this is the entire piece of code for controlling the servo. That's basically it. To run that, you obviously you just click the run button, which is down the bottom here. So I hit run, and it uploads the code, and then it starts running it. So it's now running. So if I twiddle this, you should see my servo move. So I can move to any position. I can do slow moves. So I can move it slowly. I can start, move it slowly back the other way. I can go fast. I mean, there's a limit to how fast it goes, but it's absolutely fine for the application, which is for some steering. So that's it. Really simple. And the nice thing about this setup here is the development is very fast. If I go, there's a print statement there. If I just go and uncomment that out, I can just hit the run again, and there you go. And it's now implemented with the print statement. So you can see that, compared to Arduino, where you've got to do compilation and all the rest of it, this is much faster for development, and the code is much simpler. So all round, it gets a big thumbs up from me.